Chapter 6 waves. Course revision. Yalla. Again, tops excluded, huh? Differ between a pulse and a wave. Wave is I'm sorry. A pulse is one disturbance, wave is repeated pulses, right? Yeah, wave is a train of pulses. Right? Read over this if you want. But a pulse is a general disturbance. Please, guys, good questions. حتى in chapter 4, if you want to revise, if I were to give you advice, if you want to revise something and you need to know them by heart, it's the good questions, okay? Because 90% of the good questions come, okay? And it's a rule in Sabbath. If not 90, I think it was 80. Either 80 or 90%, I forgot the number. But 80% or 90% of the grids are supposed to come every exam. It's a rule, okay? Is energy and matter transmitted by a wave? Okay, we know energy is transmitted but not matter, right? A wave transmits energy but not matter. Okay, define compression and refraction. Okay, you guys know in transverse waves, longitudinal waves, when they're close together, you get compression, and when they're far away, it's rarefaction, right? في شي diagram هون ما في. Let me give you a nice diagram. قول عندك these lines, okay? You have a dense area, and then it continues, and you have spaced areas, okay? Then it continues normally. Okay, this is obviously a longitudinal wave. What do we know? Compression and rarefaction, we know it can only happen in longitudinal waves, because longitudinal have left and right displacement, but transverse has ups and down, right? طيب, this is longitudinal wave. Okay, when الcompression بيكون هون. When الrarefaction بيكون هون, where it's all spaced out. Okay, define a progressive. When أنا? Yeah, 4. Define a progressive transverse wave. Give examples. Define a progressive longitudinal waves. Give examples. Okay, a transverse wave is one that's displacement is up and down, right? They move in direction parallel. Okay. When أنا? Yeah, transverse wave is a direction normal to the propagation of the wave. I told you they go up and down. The wave is going to the right. Isn't this perpendicular? Normal, right? شايف? So usually when they ask for direction, you say it's normal. And this comes in the exam, multiple choice. I remember it was matching. The transverse wave, it's normal. The direction of it is normal. But longitudinal wave, it's parallel. The wave's always going like this. What's the difference with transverse wave? The displacement of it is straight. Okay, so see how it's normal. However, for a longitudinal wave, the wave is still moving to the right. What does longitudinal wave? How does displacement look like? It looks like this. Okay, parallel to it. Okay. What are examples? A transverse wave. The first one you can think of is a water wave, and the second one is EM waves, electromagnetic waves, like light. Light is a transverse wave. A longitudinal wave. The first example you can think of is sound. Describe the movement of air molecules and the pressure variation as a sound wave propagates through air. Let's take a look. As a sound wave propagates through air, what is sound? Sound is longitudinal wave. Okay, what do we know about longitudinal waves? What happens in longitudinal waves? You have compression and rarefaction, right? Where's pressure maximum? Pressure is maximum in the compressed areas and minimum where? In the rarefaction areas. Why? Because in compression, they're all so close and cramped, so there's a lot of pressure. But in rarefaction, they're spaced out, فما في pressure. Okay? Question 6. To what category of waves do sound and light belong? Sound is longitudinal, light is transverse. بسرعة يعني. They want like this. Sound is mechanical. Okay? And light is electromagnetic. Why is it mechanical, by the way? Because it needs a medium to travel through. Okay. 7. Sound is thought of as a train of pulses traveling in a medium. How is sound produced? Sound is produced through vibrations, right? Mechanical disturbances or vibrations. Mechanical disturbances, yani vibrations. Okay. When you hit a table, when I clap, anything that causes a mechanical disturbance or a vibration, that's what causes sound, right? Would you expect sound waves in air to be transverse or longitudinal? Akid, it's going to be longitudinal. Explain why. Because it has... why would something be longitudinal? Because its displacement is in the same direction as the wave, or parallel to it, like we said here. Okay? So, if someone asked you why is something longitudinal, don't say because it has rarefaction compression. Although that's correct. But the first thing you should say, because what differentiates a longitudinal wave and transverse wave is the direction of displacement of the wave. Okay. Question 8. Define sound waves. What is a sound wave? It's a mechanical longitudinal wave, right? It's a longitudinal wave. Since it's mechanical, needs a medium to travel through. cans connected by a rope can form a primitive interphone. How can you explain that? Let's see. Okay, this looks nice. The sound waves in the first can vibrate the bottom of the can back and forth. These vibrations propagate through the string, pulling the string back and forth. Therefore, the bottom of the second can will start to vibrate back and forth at the same rate of the bottom of the first can, hence producing the same sound. Whatever. I'm sure you have. Let me show you a picture of it. I'm sure you guys have seen this somewhere before. Like you see these two girls, they're talking on the high. So she can hear her because of the explanation we just heard. So what happens is this girl speaks into here. Let me use red. Okay, this girl speaks into here and she creates vibrations, and those vibrations travel across the string and vibrate over here in the can. So this girl here can hear what she's talking about. Okay, basically that's pretty much it. Okay, a train of waves travels in a stretched spring at a rate of 2 waves per second. Find the period. Okay, period, frequency, whatever. Type. Period, remember, f is equal to 1 over t, right? So t is also equal to 1 over f, right? These two formulas are the same thing almost. Okay, so هنا قالوا لنا 2 waves per second. What does that mean? Frequency. Okay, frequency is the amount of waves per second, remember? Okay, for how do we find the period? It's just t equals 1 over f, so 1 over 2, which is 0.5. It should be 0.5. It should be 0.5. I think they forgot to put the answer. The time for one complete cycle of a musical note is 4 times 10 to the power of negative 3 seconds. Find the frequency. So هلا they gave us for one complete cycle is 4 times 10 to the power of negative 3. What does one complete cycle mean? It means one period. Okay. Find the frequency of the sound. F is equal to 1 over t. Okay, so 1 over 4 times 10 to the power of negative 3. Okay, and you get 250. Akid, you guys should know that the unit for frequency is hertz, and the unit for period is seconds. Okay. Part C, a radio station broadcasts at a frequency of 100 megahertz. Find the period of the electromagnetic waves it broadcasts. Again, T is equal to 1 over F. فجست 1 over 100 times 10 to the power of 6. ما بدها at all. 1 over 100 times 10 to the minus 6. You get 10,000 seconds. What? They asked for period. What? What? I think this is wrong, because they gave us frequency and they asked us to find period, but here they said f is equal to 1 over, they're finding frequency here. I think it's wrong here, but maybe they meant to say that this is the period. I don't know, and they're asking for the frequency. But whatever I did is the solution to whatever is written here. Okay. Draw and label a displacement position graph of the particles along the wave train at a single moment. Okay. Displacement position. This came in the exam. Displacement position graph. Displacement يعني here x in meters. Position يعني position s in meters. Okay. Type. Or the other way around. خلاص عادي. It's fine. Okay, and it looks like this. Right? What do we know about this distance? In a displacement position graph, this is obviously the amplitude. Type, okay, what is this? The length of the wave in a displacement position graph. In a displacement position. It's wavelength.
A mutation should spawn my server.
Okay. What if in the exam, what did they do? They came and changed it to displacement time. Okay. Displacement time. X in meters. Displacement time, so in seconds. What is the length of one wave now? This is now the period. Okay, I said this in my quiz last time in the wave CA, and I told people it's gonna come displacement time in the exam. Okay, no, قصدي بالعكس. In the quiz they gave displacement time, and I told you in the exam it's gonna come displacement position. Please put for the length of one wave is gonna be wavelength. Okay, and people still managed to get it wrong. I told you literally the question is gonna come. Well, people got it wrong. I don't know why. Anyways, so you should know displacement position it looks like this عادي. Okay, lambda by the way means wavelength. Okay, so displacement of particle A position, very easy. You should put the unit meters and meters. Okay, you should, I'm pretty sure you get marked off if you don't put units. What do they ask maybe other than displacement position? Displacement time. Displacement time would be the same thing, except the length of one wave, it wouldn't be the wavelength anymore. This wouldn't be the wavelength lambda anymore. No, it will be what? The period t. Okay, and my shitty open board is lagging.
Double check.
Oh, but here they're asking displacement time. Okay, فخلاص we just did it. I'll just show you solution. Okay, what's the difference between these two? Here, the length of one wave from crest to crest, or trough to trough, or from 0 to 0. It's now what period. Also, by the way, wavelength would be this. This is also lambda. If you go from trough to trough, or this is also lambda. Lambda. Okay, and you can. There's 3 different ways to measure lambda. طيب, define frequency, wavelength, amplitude, and wave. I'm just gonna show you a solution. Okay, because this comes. Wavelength is the length of the wave from one peak to the next. Frequency, and this can only be found in displacement position. From the displacement position graph. If you have displacement time graph, you can't find out the wavelength. Okay, frequency is the number of cycles per second, right? Amplitude is the maximum displacement, so usually the height. Speed is the distance per unit of time. Yani easy. What is the speed of frequency and wavelength? This. You know that V is equal to lambda f. Okay, let's do it here. Okay, V equals lambda f. Lambda is 750 but nanometers. Nano means times 10 to the power of negative 9. Okay, so V is equal lambda f, so 750 times 10 to the minus 9 times the frequency 4 times 10 to the power of 14. And you get 3 times 10 to the 8. That's light, by the way, huh? Which sound travels faster? Let me just mention this because he got it one time and a lot of people got it wrong. Velocity of sound, light in air, water. Okay, sound in air is around 340 meters per second. Light in air is 3 times 10 to the power of 8. In water, it's around 1,500 meters per second. Okay, in light, in water is about 1 point, I don't know, 2 point something times 10 to the power of 8. I don't know. But the point is, you need to know this. Okay, here. Okay, this is important because he got it with a past. I think I saw it in a past paper as well. It came in our mini mock also. Okay, because many people think, oh, sound in water, yani it's slower. No. It's actually faster. It was 1,500. Okay, which sound travels faster, a loud sound or a quiet one? I think it's the same, right? They travel at the same speed. Okay, we know that speed, just so you can understand this, the speed is lambda times f, right? Type a loud sound or quiet one. What differentiates a loud and a quiet sound is the amplitude. Type, does this formula have amplitude in it? No. So if you have a higher amplitude, lower amplitude, it's not going to change anything. Okay, the speed of propagation of sound does not depend on the amplitude. It does not depend on the amplitude. It only depends on the medium in which sound is propagating. Which sound travels faster, the one produced by a guitar or by a drum? شو بيعرفني, man? Both sounds travel at the same speed in the same medium. Okay, if in the same medium, they travel in the same speed. Okay, خلاص. Okay, waves in the same medium travel at the same speed. Take it as a rule. Wave A undergoes several changes to give W, X, Y, and Z. Okay, describe how the pitch of A changes in W and Z. Okay, let's see. Pitch depends on frequency. Which is higher pitch, this one or this one? Actually, this is going to be this one, right? Here, there's a higher frequency. W has a lower frequency than A, but Z has a higher frequency than A. Okay? How about the loudness in X and Y? Okay, in X, it's obvious the amplitude has increased. So amplitude, it's louder in X, but quieter in Y. Okay? Very straightforward. Do different sound pulses. How many do I have? Just 2 pages? 3 pages. Okay. They're not bad. Where are we? Do different sound pulses pass through each other without change? How can you justify that? So, this is called interference, right? When waves or pulses يعني hit each other, right? So let's see here. This is the justification. So do they pass without change? No, obviously not. We know this. Definitely it doesn't pass without change. It either go constructive or destructive interference. No, and how is it justified? If two loudspeakers are placed facing each other and the microphone is allowed to move between them, then the microphone will detect regions of amplified sound and regions of little or no sound at all. Okay, so this is just a justification in case they get it for you in the multiple. Uh, do different light pulses pass through each other without change? How can you justify that? Same thing. And Akid, no, it doesn't. Under certain conditions, they undergo interference. Light is a wave, okay? Well, it's both wave and particle. But you need to know that it behaves as a wave as well, okay? So waves in general, they don't pass through each other without without any change. Okay, you need to know that. Draw two waves that interfere constructively and two that interfere destructively. Okay, let's draw them. Okay, هيك. Okay, هيك. These two are in the same direction. So if you call this A, then the resultant wave will be like this. Okay, where this is 2A. This is what we call constructive interference. بس إذا عندك هيك okay, this is A and this is also A, then what are you gonna get? You're gonna get just a straight line. Okay, so let's take a look here. This is destructive interference, this is constructive interference. Okay, and if they were to draw the resultant, it's gonna be 2A here, a big one, and here it will just cancel out. Okay, does sound pass through and reflect from a barrier simultaneously? If you clap your hands 30 meters from the flat window of a building, can you hear the echo? Can people inside the building hear you clap as well? Let's see. Yes, sound is transmitted and reflected at the same time. Of course, when you stand and you scream, you can hear an echo, right? Why? Because you will hear, you see, you hear the echo of the clap. Why? Because the sound is bouncing off all the walls. Okay. And yes, of course, people inside the building can hear the clap. These are stupid questions. Okay, reflected pulses. What do we know? We have reflections for free ends and fixed ends, right? What do you need to know? If it's a free end, it's gonna come back in the same direction. But if it's a fixed end, it's gonna come back in the opposite direction. Okay, let me show you. So the reflected pulse, if it's a fixed end, okay, is gonna come back in the opposite direction, or flipped vertically, upside down. But if it's in the free end, it's gonna be back in the same orientation. What do you need to know about reflection? It will have the same frequency and same speed, okay, as well as the same wavelength. Okay, a plane wave strikes a straight reflector as shown below. Draw the reflection of the wave after reflecting. Okay, you just continue it, okay, and draw the normal to the plane, okay, and continue it. It reflects back like this, right? You guys know that the angle here should be equal to the angle here, okay? You have to also draw the wave fronts. These lines. Okay, the spaces here should be equal to the spaces here. Not that hard at all, wallah. Okay, just continue the line. Okay, if anytime you want to draw reflected, continue the line. Okay, you need to draw the normal. Okay, so you find out how it bounces. Okay, to draw the normal, you just draw a perpendicular straight line through the boundary. Okay, continue, take. Okay, make sure that the angle here is equal to you. Obviously not exactly, and the teacher isn't going to mark you with a protractor, but make it look the same. And over here, see, it's not the same. Let me fix it. Okay, please use a pencil for this. Oh, I don't want you asking for another written part. And then you just draw these wave fronts, making sure that they're equally spaced the same way it is here. Okay, a ruler would help. Okay, type. This is called reflection. Okay, so let's take a look at the answer. Oh shit, wait, I'm so stupid. أكيد. Okay, I don't know why I continued it out here. If it's reflecting, it should bounce back. When it goes here, it should go back up here, right? It should look like this. My bad, no? Reflection. The other one I drew now is refraction. Let's forget about that. Okay, yeah, it should bounce back like this with the wavefronts. You see? When a water wave travels from shallow water to deep water, it changes its direction. Okay, what wave phenomenon is being observed? Okay, this is what refraction. How does the speed and wavelength of the wave change? If you're going from shallow to deep, okay, shallow to deep, okay, it should be getting faster, right? Yeah. But you guys know in shallow water, since there's no space, the wavelength is small. Okay, but in deep water, since there's a lot of space, wavelength is large, right? Type. What do we know? What happens? What happens when you have a larger wavelength? مش v is equal to lambda f. طب when you increase lambda, what's gonna happen to the speed of it? It's gonna increase. Whenever you go from shallow to deep, it increases. But نحن in the examples they gave us always, it's from deep to shallow, so that would be slowing down in that case. Okay. Here, what is changing here? The direction of the wave, because they asked it what changes in reflection. It's the direction. It was either this one or this one, I forgot, but the property being changed is the direction of the wave. How does interference pattern depend on the wavelength? Let's take a look. Okay, spacing is directly proportional to the wavelength. Did we do this now? This is the diffraction slit experiment. Yeah, okay. Type. If you remember, let me open for you the slit experiment. 1 second. For the young slit experiment is the one where we shine rays and we poke two holes, right? We poke two nice holes here. Okay. And basically we stick the rays through the hole. Oh, not like that. But whatever, you shine the rays and they're gonna go through the holes, right? Type. What happens here is you're gonna have waves and whatever, and at some of them you're gonna have constructive interference where you're gonna have a light. You see, like see over here, there's light, and some of them you're gonna have destructive interference. So there's gonna be no light. So as you can see here, there's no light. It's white. Okay, and here you have light. There's light. Okay, what do you need to know? You need to know that it's the brightest over here in the middle. Okay, so as you can see here, this is how it would look if you're looking at it in real life. Okay, so this is how it looks. It always alternates. Okay, it always goes bright, not bright, bright, not bright. Okay, it always alternates. Okay, so what are they asking here? They're saying, how does it depend on the wavelength? How does it depend on the wavelength? If the wavelength is larger, these spaces are going to be bigger. That's pretty much it. Okay, spacing is directly proportional to the wave. But if you increase the wavelength, the spaces here is going to be larger. Design an experiment using double slit to the interference of light. Place a cardboard with two small slits, like here. Okay, separated. Where's the solution? Separated by a small distance in front of a screen. Shine a laser, and observe the screen in a dark room. A system of alternating bright and dark fringes that are equidistant. Equidistant is the keyword, and parallel to the slits is formed. Not too hard at all, yani. Question 25. Once a water wave reaches a narrow barrier, it spreads out after the barrier is shown below. What wave phenomenon is being observed? Akid, this is what? Diffraction, right? You know, when it comes to a hole, it's straight, all of a sudden it starts curving. Michael sends a train of sound waves into a barrier. The waves leave the barrier, making the shapes below. How can Michael make the waves spread out more after the barrier? List two ways. If you want to spread out more, you decrease the gap. Okay, so it's gonna go like this. Okay, if you wanted to spread out less, you widen the gap. Okay, so let's take a look here. If the size of the hole is the same order of size of the wavelength, then the waves will spread out or diffract. The smaller the hole, the more the waves will spread out or diffract. Therefore, in order to make the waves spread out more, Michael can reduce the size of the barrier or increase the wavelength of the incident waves. Okay, he can either make this gap smaller, okay, or make these a longer wavelength. Okay, because if it's a longer wavelength, actually it's going to be more spread out. But so what they usually ask for is what happens when you widen it or make it tighter. What is the distance between adjacent nodes? Where are the antinodes situated? Oh, no, standing waves is not part of our material. Okay. Yeah, we don't need 6.11. It's not part of our material. I'm recording for the periodic, by the way. I thought it's all of chapter 6, but apparently it's still 6.5. But if you reach this point of the video, you're probably watching for the finals. So I guess that's good. I recorded for the finals. Anyways, thank you so much for watching and good luck.